take the difference between TAC, TAB. So basically, last 20%. Last 20% of the fall is from B to C. And the time corresponds to that equals 4.28 seconds minus 3.83 seconds. If there's someone who did not get this, when you are watching this video again, things will come to you. Pay attention that I put the A's and B's and C's on the bridge. And first I found the time from A to B. Then I found the time for the full motion A to C. And then I subtracted A to B from the full motion. And that's how I ended up with this number. So 4.28 minus 3.83 is what, 0.9 something? Point 0.45 seconds. And the time from B to C is 0.45 seconds. Is that right, guys? Yeah, 0.45 seconds. And then the next part of the question asks us, what is the time, what is the velocity when you start the last 20%? If you look at the question again, it asks you, what is the velocity when you start the last 20% of the motion? Good thing that we found the time from A to B. We have the time from A to B, and B is the time that the last 20% start. I mean, B is the starting point of the last 20% of the fall. Since we have the time from A to B, as 3.83, regardless, the initial velocity stays as 0. Acceleration is negative 9.8 meter per second square. So they all stay the same. And the only thing that we can do at this point is finding the final velocity, which is done by using the first equation. So final velocity equals negative 9.8, and the corresponding time, this is actually seconds, okay, 3.83 seconds. And then you will get a negative value because it is pointed in the downward direction. What do we have? Thirty-seven point five three meter per second. And that is the velocity of the bolt as it reaches the beginning of the last 20% of the fall. The negative, yes, thank you. Thank you, Jacqueline. Yes, negative 37.53. Wow, you guys are paying attention. Very good. Very nice. So negative 37.53, and as I said, the negative indicates that the direction of the velocity is downward. And then the last part of the problem asks, where is it? What is the velocity when it reaches the valley beneath the bridge? That means the velocity at point C. the velocity at point C. And again, good thing that we found the time corresponding to the full fall as 4.28. So you can substitute T equals to 4.28 in the same equation, and you can find the answer. I am getting the answers as 42.04 meter per second as the final answer. But let's check that. So from A to C, we have the time. From A to C, the time is 4.28. Time is 4.28 seconds. And then we have V final equals V initial plus AT. V final equals V initial negative 9.8, 4.28. And then the final velocity at the impact is 42.04 meter per second. Again, I'm copying from the chat. If you have a different answer, please correct me. Negative 41.94. Can someone tell me what you get 9.8 times 4.28? Is that negative 41.94? Yeah. So negative 41.94 meter per second. And the student who sent me 42, maybe they were using 9.81 as the gravitational acceleration. And that's 100% acceptable. No need to worry about that. However, the Weber sign is giving you the accelerations, and then you are supposed to use what they give. But in this case, in these cases, the acceleration is not given, so you don't have to worry about the 9.81, the use of 9.81 or 9.8. Since I am using 9.8 in the class discussions, you can use 9.8 as well. But if someone is used to use 9.81, they can continue with that. I received the answer to the other problem as well. But I mean, I know that everyone is not at the same level. Therefore, in order to keep those who did the work occupied, I am going to assign you all another problem, and I'm going to look at problem number 53. So the students who are done with both problems, I would like you guys to look at problem number 63. Problem number 63. If you are not done with 53, just take a picture of 63. I will return to this later. This is only for those who were sending me the answers to number 53. I have some answers already for 53. So those students, they can actually take a picture of number 63 here. And then I am going to move back to number 53. All right. So here we go, number 53. Since I am posting these videos, you have the problems along with the video. Now, number 53 says, a key falls from a bridge that is 45 meters above the water. It falls directly into a model boat, moving with constant velocity. That is 12 meters from the point of impact when the key is released? What is the speed of the boat? Now, if you guys remember, at the beginning of the class today, I told you that after I introduce the vertical, I combine vertical and horizontal motions together. And this is one such place. A key falls from a bridge that is 45 meters above the water. And again, you have one of those magic words, the word fall here. Fall means initial velocity is 0. And then the height of the bridge is given to you as 45 meters. And it falls directly into a model boat moving with constant velocity that is 12 meters from the point of impact when the key is released. Another word used there was released. Released and the fall and drop, they all stand for the same meaning. Initial velocity is 0. So if I were you, I would actually draw a little cartoon to represent the initial moment of the situation. Number 53. So let me remove this and then get back to work. So number 53. So this is the bridge and this is the boat. And here goes the key. This is how it looks like at the beginning. The boat is 12 meters from the point of impact. So this is the point of impact. The boat is 12 meters from the point of impact. And then the key falls 45 meters down. So just like the problem that we started today, here we have two objects. One is the key and the other one is the boat. Now, what can you guys tell about the time it takes for the key to drop to this point and the boat to come to this point? What can you say about those two times? Yeah, good. Yeah, I'm looking at the chat. Yes, they must be the same in order for them to meet. So going from A to B, and then here let's say C to B, the time it takes from A to B versus C to B, they should be the same. Otherwise, the key will not meet the boat or the boat will not catch the key. So we are going to write down the information for the key and the boat separate. Now, another question that I would like you to answer. The boat has a constant velocity. What is its acceleration? I expect at least 10, 15 answers. The boat has constant velocity. What is its acceleration? Pretty good, pretty good. Constant velocity means like you are driving your car with cruise control. What is the acceleration? 0. So for the boat, acceleration is 0. And the distance it travels, 12 meters. Initial velocity and final velocity, they are the same and we don't know that. Why did I say initial and final velocity is the same? Because it says constant speed. It says constant speed. And the time, I don't know what the time is, but I'm going to write it as t because it's the same that I'm going to put here for the key. And we know a little bit more information for the key, and I still take up as my positive direction for that vertical motion. Initial velocity for the key is 0 because it's released or dropped or fall. And then V final, I don't know. Acceleration, negative 9.8. The delta y, that is the displacement, negative 45. And the time is the same as the time that I have for the boat. They are the same. So if I use first of all, what equation should we use to find the velocity of the boat or the speed of the boat? Well, it is reasonable to use the second equation in this case because acceleration is 0 and the initial and final velocities are the same, and we have the displacement. So I'm going to write the delta x equation, VIT plus 1/2 AT square. A is 0, easy, that term goes away. So here I have 12 equals to V initial times T. That is my first equation. And for the key, we have, as I said, lot of information. But again, we can use the same equation, second equation, VIT plus 1/2 AT square. If I use the second equation, immediately the first term goes away because V initial for the key is 0. So delta y is given to us plus 1/2 negative 9.8 and t square. So you have 45 equals 4.9 t square, and the t you can find from here. And this is for the key's motion. Once you find the t, you can use that in the equation up there that we wrote for the boat, and then you can find the final or initial velocity of the boat. As I said, initial and final velocities are the same for the boat, so it doesn't really matter which one you find. All right, so again, send me the answer for the time here. 45 divided by 4.9. All right, thank you. 3.03 seconds. And then when you plug it in here, when you take it to the equation over there, because it's the same time that they are sharing, 3.03, you can find the speed of the boat, V initial, 12 divided by 3.03. So I believe it is also 3 point something, right? Thank you. 3.96 meter per second. And that is the speed of the boat. Now, when I am doing these things, these problems, I always set up the table, and I strongly advise you guys to set up the table as well. Because when you set up the table, it is easier for you to understand what equation to use. And you need a lot of practice to decide what equations to use. And for me, it is easier because I'm teaching this like a long time. And then I know what equation to go for. Now I have a question. What happened to the other part of the equation? Well, I believe that you are asking about this part here, but again, did you see that acceleration is zero? Acceleration is zero, so that term goes away. I mean, if you like to call this plus zero, that's fine, but the acceleration actually goes away. That's why the other part of the equation was missing. But thank you for asking the question, because there must be some other students who are wondering about what happened to that second part of the equation. And then understanding that the time is equal for both motions is very important. Otherwise, you won't be able to even start this problem. Partial credits will be given for every little thing, like setting up the table, you get a lot of partial credits. Choosing the correct equation, you will get the partial credits as well. Let's say that you started with the wrong started the problem using the wrong equation and went up to a certain point and then decided to change. That's also not a problem. You will get like you can stop where you whenever you find a road bump, and then you can move on to the next equation and continue. All right, so I will post all the recorded videos, and if you guys have any questions, please ask me when I'm on campus on Thursday. And thank you very much for coming in with a very short notice. All right, so your quiz on Thursday will be based on what we discussed today. And this is the end of the chapter. No lab today, right? No, actually, there is a lab. This is the week that we start the labs. Week of February 3rd, we start the labs. All right, guys. Bye. Oh, who has COVID cancelled? Charlie, who is that? Hmm. Yeah. Okay. Bye, guys.